Hello everybody, my name is Hannah Jacobs and today I'm going to be talking about my Desmos project, which I decided to show the Build a Bigger Field activity. So, in this activity, students will use the quadratic models to optimize the area of a field for a given perimeter. So that is the main points that we are going to be hitting today is area and perimeter. Before starting this assignment and activity with any classroom, we need to make sure that students already have a prior knowledge that the perimeter is the distance around the outside of a shape and that the area measures the space inside of a shape. So before beginning, a couple of teacher notes that I found within the teacher guide over here in the right hand corner was to notice here that the screen suggests students and teachers use a laptop, not a mobile device or a tablet. So the teacher needs to make sure that each student has or is provided with a laptop to complete this activity effectively. And one last thing is that we need to make sure that we are providing an effective pace when teaching and a pause ratio to ensure that students just aren't copying off of their peers and making sure that they understand the information successfully. So as you can see, I have the Math 245 as my class listed below. And to assign this activity to a class, all you simply do is hit this green button over here that says assign. So you click that. So the next thing that they're going to be doing is sketching the relationship. So they're going to be taking the points from their previous question, number 6 and number 5, and they are going to be continuously using these to further advance. So they are going to be sketching the relationship that they find with the points that they found. So on my screen, it's going to have the individualized points that I have created. And it says graph data. This graph shows all the fields our class created today, which there would obviously be more. Your points are in orange, your classmates are in blue. So if I had some classmates' results on here, they would obviously be in blue, but since I am the one who created these, they are in orange now. So the question asks, what function family do you think best describes the data? So when looking at my points, we can see that it does create a shape. And looking at this shape, if I had a pen now to try to show you, you would see that it's opening downward. And knowing my previous knowledge, I would know that that means that it is quadratic. To further this thinking, I would explain what I already know. And I think that this is an excellent tool for the teachers to have to see that the students aren't just clicking quadratic just because they just decided to choose it. They would actually have to explain that the shape that the points create, in this case, open up as if they are a parabola. Pardon if I said that wrong. And so that way, since I know that that is the shape that it is created, I know that it is a quadratic function family. So for this problem, we are asking, what is the area of any old field? One with 50 meters of perimeter and length x. That's what we're finding. Show your answer in the table. Okay, so to go ahead and do some further examples, I want to go ahead and walk through each one of these before we determine D. So for A, we can see that we have 4. So to get our perimeter, which is 50, we know that there is 50 total around the outside here. So we know the 4, which means this has to be 4 too. If we add those together, we get 8. So we would do 50 minus 8, which equals 42. And then to find these sides, to find what's left, we know that there is 42 between the two of them, so we need to divide that between 2, getting 21. So we would have 4, 21, 4, 21. Okay, so for problem B, we have 17. So we would also know that that's 17 on the bottom. So 17 plus 17 equals 34. So we know that there is a 17 down here as well, as I said. So we would take 50 minus 34 to find out what we have left to split between these two sides. That would equal 16. So 16 divided between the two of these, 16 divided by 2 equals 8. So that means these two sides have to be 8 and 8. For problem C, we have 11. That is the number that they give us. So we would take 11 plus the 11 on the other side and get 22. So 50 minus 22 is 28. That means we have 28 to divide between these two sides. 28 divided by 2 would equal 14. So we would have a 14 on this side and a 14th on this side. As you can see, for D, we do not have a number. We are not provided with a number to be able to find each side. So as this is an X, we would automatically assume this would be an X as well. What we would put in our box would be 50, as that is the perimeter, minus X, because that is what we are given. And that is all the information that we can provide. For the area, we would do X, parenthesis, 50 minus X, parenthesis. Again, I just want to remind you that these are not going to be the same numbers that all of your students are going to get, because these are my individualized numbers of the fields that I created back in our question number 5. So each one is going to be unique. Looking at the next problem, it says graph the function. Here is the graph of your function. We are provided with that. So, question number 1, what does it tell you about the dimensions of the field with the most area? And secondly, what is the area of that field? So what we need to do is determine where the maximum of the parabola occurs at. We are actually given the points. If we follow along the line, we can see what each point is. So it's easy to determine what the dimensions are going to be that we will have for our answer. So I'm not 100% positive. I do believe that the students will also have that, so it's not going to be a number that they have to figure out. So my maximum up here is going to be 4.37199.403. So there we have our answer. For number 12, these are extension questions. That's number 12 and 13. As you can see, they say extension at the top, and I would use these as a review item just to see what the students are actually feeling after the lesson. I would take those for points, I do believe, because just so we can see kind of how they would do if they were assessed on the material right now after just going over all of the material. So just taking a look, extension number 1, let's say you don't have 50 meters of fencing, you have 60 meters. So make 60 in place of 50, pardon if I said that wrong, or 600 meters or m meters. Write instructions for how to find the dimensions of the biggest field given any length of fencing. use a sketch tool if it helps you illustrate your thinking. So basically, this is kind of an open-ended question for the students. It is and it isn't in a way, because the students could click back through the questions and figure out the correct process that we use. They could do it piece by piece and explain it that way just by substituting numbers. But it really is their own answer and their way of explanation. It's just the matter of if they fully understand the way to do it. So I think that, like I said, I would use these extension questions as a way to actually check out what the students are actually understanding. Students could also work together on this, work with a partner work to see maybe they might be having trouble with it. So I think that it would be a good idea to let them work with their peers on this one. So as a teacher for the extension, same thing would happen. The responses would come here. I would give the students, I would not put the pacing amount on that. I would let them work on those two questions at their own speed as long as they get them finished. That's all that matters. So it's just them generalizing their ideas beyond the one particular example that we went over. And it's honestly a really crucial step that it's worth spending some time on, and we could do these as a large group after everybody finishes it, just as one final review before the test, assessment, pardon me, or even just walking around to each group and helping them work through it if they're having problems. So I think that looking in their responses, we could look at the different approaches to see if everybody is just following the same format that we just went through, and just having the students share with each other what they're doing to see if they can have a connection among the different approaches that they are doing. I do hope that throughout this video you did personally have a better understanding of area and perimeter and how to teach it as a different approach by using the Desmos website. I definitely will be using this as a resource to use in my future classroom, and I think that it is a really great way to have the students be following along with you, especially with that pacing icon. So I do believe that Desmos is a really great resource to have, and I hope that this helped. Thank you very much.